everyone. Welcome to stage 2. This is the talk Stairway to Heaven, scaling frontends the right way. Thanks for joining. My name is Florian Rappl. I'm a solution architect at a smaller company called Smapiot. We are mainly doing IoT and embedded computing, have a lot of projects in the digital transformation space, and I'm specialized on distributed web applications. Besides my professional work, I'm also spending a lot of time in the open source community. I would refer to myself as an open source enthusiast. I'm a Microsoft MVP in the development tools space, and I mostly do projects with tech stacks involving .NET and JavaScript, TypeScript, Node.js, and React. I'm also writing blogs for various sites and also magazines. And in this space, I've also written a book, and this will be part of the topic we have today. If you want to grab it, this is a copy of it. Also, just message me. I got some discount codes. In the meantime, I've also written another book. So if you want to improve your Node.js development skills, then check this one out. It's called Modern Frontend Development with Node.js. But enough about me. Let's get right into the topic, scaling frontends the right way. So let's say you have never heard about the term scalability, or you may have heard about the term scalability, and there are a lot of things that may come to your mind now. And actually, there is not one definition in the software space what scalability is, because depending who you ask, you will get different answers. So for instance, if you ask a developer, well, what is scalability for you? You might hear things like, well, for me, it's the first time to make a commit to a project. Or a project that seems really scalable to me if it's quite easy to do deployments, for instance. And I mean, there's nothing wrong with those two statements. A first time to commit is quite often a good measure to see if an architecture was quite scalable and if it is, for instance, scalable to onboard new team members. Also, for instance, from a DevOps perspective, the ease of deployments is quite important for scalability. So therefore, again, that might be some valid points that you raised there. However, again, there are more personas. And if you, for instance, would go more into operations, they would tell you something else. They would, for instance, say, well, for us, it's really important that the project is able to handle the traffic well. So for instance, if there's a Prime Day and we get a lot more offers, then we need to be able to scale up and actually handle the traffic. Also, of course, our whole infrastructure needs to be resilient to failure. So if one subsystem goes down for whatever reason, it shouldn't affect the rest of the system. Now, all that, again, is true. But it's not the only perspective. There's also a business side, and they will tell you something completely different. So they will say, oh, for us, scalability means it's a fast time to market. So whenever there is a new opportunity or a challenge coming up, maybe a legal requirement, who knows, then bringing that from, let's say, idea, conceptual phase up to production shouldn't take longer than needed. So there shouldn't be any showstoppers or roadblockers here that are artificial. It's really the fastest track possible. And in essence, that also means that usually business people expect no feature slowdown, even though we know that when applications grow and grow and grow, quite often, technical debt also accumulates, and it gets slower and slower to actually bring things and ship features to production. So in my opinion, if we want to summarize and bring it all down to one point, we could say that scalability in general is the ability to handle changing demands on a business. And that means, for instance, that you got new team members, and that might be a changing demand, right? And you need to be able to onboard them. That also means that traffic spikes and you need to be able to handle that. And that also means that there's a business opportunity and you need to be able to ship a new feature. And so scalability is all about being able to handle these things as quickly as possible. Now, luckily, on the web, we never stopped. So in the last 30 years, we always found ways to, well, first solve things practically and then grow with the challenges. As an example, if we look back, we all started with a monolith. So I personally started back in the mid-90s. Everyone was talking about this web thingy, and I also wanted to have something. And of course, started with a little static website hosted on GeoCities until someone said, that site sucks. It doesn't even have a guestbook. So how do you do that? Well, luckily already CGI was a thing, and so you got into Perl and you programmed a little bit what would now be a server-side rendered web page. So a little bit of a dynamic site that was handled to, of course, receive form posts, store it in some database, and reflect that on the screen when you enter that guestbook, for instance. And that single kind of system where front end and back end were all fused together with maybe some database, that was, well, let's say, the cornerstone of pretty much all the successful startups that were born in the 90s, like also, for instance, Amazon or Google. They all started with such a monolithic architecture, and there's nothing wrong with that. You can still scale it, have a load balancer in front of that, and it works. So all fine. However, new challenges arise, and we all can remember when, for instance, Google Mail, but also Google Maps came out, and that changed the landscape of what you, let's say, expect from a website forever. Now, these sites were in parts updated, and part of that was because they used a technique called AJAX, so asynchronous JavaScript with XML, because they were communicated to special kind of endpoints, what we now refer to as APIs. And the website got updated data, and it just then updated parts of it, which made sense, right? And that was great because this is what we today would call more or less a single page application, but make no mistake, it doesn't need to be. Maybe just parts of the page are with this interactivity and the connection to an API. Nevertheless, having the API was an important stepping stone, because the next thing that happened was the mobile web, right? So suddenly the mobile devices were entering the space, and they required, on the one hand, maybe different websites, but on the other hand, they shipped with new applications, native applications, and they also demanded data, of course. So long story short, they needed, of course, a way to access it, and luckily already the backend was prepared for it. But not entirely. You needed maybe also some new APIs. Some old APIs were stressed more than others. And the end result was that there was more focus on the backend. We needed more scalability on the backend, and new kinds of, let's say, architecturing the backend came up. And what we now know is the microservice kind of pattern, which is not, of course, a single pattern, but rather, let's say, an umbrella term of distributing or breaking up your monolithic backend into different services and aggregating them potentially via backend for front end or some gateways, right? And this is highly successful and quite often the architecture of choice, even though, of course, there's, again, nothing wrong with a monolithic backend or a monolith at all, depending on the project that you have. Now, there was this focus on the backend, and I mean, that was solved pretty nicely. But we are coming back in full circle, right? And now the focus is on the front end again. So websites are growing and growing. You want to centralize services. You want to have more development capacity here. You don't want to have a feature slowdown. And most importantly, you might want to align your development with the backend, because now that the backend is super scalable, well, new kind of services are maybe, let's say, created on a weekly basis. Who can keep up in the front end, right? If the front end is monolithic too, you might struggle here. So the end result is that there's a new kind of style coming in, and this style is known as micro frontends. And as you can see from this picture here, it mirrors pretty much what was done on the back end. So instead of having now different services, we now have different kinds of front ends here, or let's call it UI fragments, and they are then aggregated in a layer that we could call app shell, which is short for application shell. So it's like an empty application because all the domain functionality is scattered out into these different micro front ends. And so far the theory. Like with microservices, there is not, let's say, one pattern to implement that. There are multiple things. There are things to watch out. And while this is, let's say, all interesting on its own, we will not focus on all the patterns, but we will rather focus on one way that makes your front end here scalable. And it all starts with the realization that potentially you might want also to distinguish between what are micro frontends and what are modular frontends. So right when the term was coined around 2018-ish, people were starting experimenting with that, and the first articles came out back then. And of course, also criticism was not far away, right? So here we got a tweet, for instance, that correctly brings up that potentially just blindly going into micro frontends, meaning that they're all just servers somewhere generating some HTML, and who knows now how to bring that together. Maybe you should think about modular frontends first. As of today, quite often these terms are used interchangeably, but you should not make a mistake here. They are quite often different. In my opinion, going for modular frontends makes more sense too, because classically, really a micro frontend means you have a reverse proxy and you have dedicated servers for your frontends. And we will see now what that modular frontend actually gives you. Also, one word of caution here. When micro frontends arrived, and even today, quite often the focus in these articles is about using different technologies. That should not be your primary concern. Micro frontends can, of course, be used to, well, let's say, establish a boundary that could be used by different frontends independent of what technology they use. However, in practice, from multiple perspectives, it makes sense to limit the number of technologies being used. Quite often, that also gives you an edge. In many implementations, also, let's say, very difficult to use multiple technologies. So there's even this. But if you really open that door, then your application usually will suffer. On the one hand, in performance, because at the end of the day, this still is, let's say, run in the user's browser, right? So having, let's say, 5 versions of Angular running in the same browser tab, will not give you any benefits. So really try to reduce here. And the other thing is the same as with microservices. Always think about maintainability. So if there's a new team, this team, well, for one of them or many reasons, chooses Svelte, great framework, by the way, but no one else knows Svelte, then keep in mind that when the members of this team, I don't know, disappear, someone else needs to be able to maintain that. Of course, you can argue microfrontend should also maybe be small, so it could just be rewritten, but still, think about the implications, and it would be good to reduce the number of technologies to something that most people agree on. Therefore, I would say using multiple technologies in general is an anti-pattern, but opening the door through microfrontends is definitely one of the things where you benefit from microfrontends. Great. Now let's have a look compared to microservices, why going fully microfrontends makes sense from a team distribution. If you look at that diagram, there are 2 halves. On the left side is what you see classically now with microservices. You have your front-end team, right? And then you have grouped around these services some new teams like a content service, attribute service, payment service in this example. And maybe there are some overarching concerns regarding business or some DevOps guild or whatnot. Now, the problem is, of course, that here all this communication is required. So business needs to talk to everyone, for instance, and everyone also talks to the front-end team, and that requires a lot of alignment. Now, the idea behind microfrontends is that you can now also form, as an example, real full stack teams, because you're no longer limited by this arbitrary boundary to the front end, right? And if you have the full stack teams, well, there nothing prevents you to also scatter the business really in these teams, because, well, now it really makes sense. There's a real product owner for this team, and this is really, the subdomain is fully covered here. So they can really work now independently, autonomously, and get things done. And therefore, you can really now go and group around these subdomains, like here they call it Team Inspire, Team Decide, Team Checkout. But each team has a real purpose and is fully autonomous. And that's great. So that's the real benefit of microfrontends. It's not a technical one, it's an organizational one. It boils all down to the distribution of work, right? So Amazon's claim, you're really good when you have these pizza teams, right? So that makes sense here too, that 3 8-person teams without additional alignment requirements are more effective than a single 24-person team. There are, of course, exceptions to that rule, and surely that's a rather a statement that you can always challenge in some projects, but nevertheless, the basic idea is, if you can work autonomously on something and you don't need additional alignment, you're more efficient. Now, people tried that out and said, oh, that all sounds great. Let's go for it, right? So what could go wrong? And turns out a lot of things can go wrong, right? Because there's a little more to it. And quite often the challenges are in the organizational aspects, but very, very often the root cause is then in technology, unfortunately. So both things need to come together. On the one hand, the organization needs to be ready and needs to make this step. But then again, this is not enough if, let's say, the technical basis is not sound, because suddenly then things will come up. Things like this, 2 years of microfrontends, a retrospective. Well, it wasn't a good one. They made a lot of mistakes, and the most crucial one we will see in a second. Problems with microfrontends, it all boils down to the same mistake we will see in a second. And the customer experience was also not very good here, and same issue. What issue do I refer to? It's strong coupling. So if you see something like this, and it may look a little bit different than, of course, this one line of code here, but you get the basic idea. You grab directly UI fragment, that's called a component, from a microfrontend. Let's say in another microfrontend or in your app shell. If you do that, this is what I refer to as strong coupling, and then essentially you are dead. The reason is you're creating a hidden monolith. And while I have nothing against monoliths, I have a lot of things against hidden monoliths. They are the worst because they don't offer, they have the complexity of a distributed system. So you get all the drawbacks that come now with microfrontends, all the challenges, right? But you don't get any of the gains. So essentially, it's the worst of both worlds. You get the worst of the monoliths combined with the worst of the distributed system or the microfrontends, and you call this your new solution, and that's not good. So therefore, don't do this. If you ever see yourself going into a strong coupling scenario, ask yourself, is this really the way, or is there a better way? Now, honestly, it's quite easy to fall into the trap. And that's why 9 out of 10 projects that we witness at smapiot, where we are getting called and say, can you consult us, please? They are making this mistake. And it's very easy because, well, if you want to go for some tooling, and let's say you choose Module Federation, which is a quite popular plugin for Webpack, which is a bundler for JavaScript or front-end code, then of course you want to see some examples, how they do it, what it can do for you. And pretty much every example looks like the one I've randomly chosen here. So this is a repository with, I don't know how many stars it has as of today, 4,000 or something like that, maybe 5,000 already, who knows. But it's very popular, so everyone who dives into the tool will come across these examples, and what you will see is things like this. Right, so the standard way how you use Module Federation, and that's the direct path they paved for you, leads to strong coupling. Why? You see it directly here, because you make a direct import of, you're not only naming now micro frontend, which is here called app2, but you also name the component that was exported by this micro frontend. They called it button. So if they now want to change their name, or if they are not available anymore, this code will break at this position. That's bad. Don't do that. And that also, of course, with the strong coupling leads to feature overlaps. So what is that? That is essentially the feature that prevents independent rollouts and rollbacks. Why? Let's say you develop a joint feature. It's the blue one. How does it look like? Well, you create a bunch of components, let's say in frontend 1, and frontend 2 and frontend 3, they also have, let's say, a component where they need to use one of the developed components to make this feature really work across the board here. So they also import it with the, let's say, the code that we've seen in the example. But what happens now? Well, frontend 2 and frontend 3, they can't just deploy, right? So they need to wait until frontend 1 is deployed, because they grab this component from frontend 1. So it can only be there when frontend 1 is there. Now they wait, have you deployed it? Have you deployed it? That reminds us already on the monolith, right? So this was one of the reasons you wanted maybe to go away from monolith, because scopes are always too large for a release. That's why you have the feature slow down. Well, you have it now here too. Well, finally, frontend 1 deploys. Frontend 2 can now also deploy. Frontend 3 can now also deploy. But now, let's say, frontend 2 says, now there's an issue. I need to roll back. Well, now this feature is maybe destroyed. But even worse, maybe frontend 2 is working fine, but frontend 1 has a problem. And they say, we need to roll back to the previous version. Well, they can't just roll back, because frontend 2 and frontend 3 already deployed. So now you need to make a joint rollback. Those are the worst. And I mean, while this now sounds easy, because it all sounds like they were quite adjacent in the timeline, in reality, it's not. And in reality, you would just roll back frontend 1. No one would know that there's a feature in frontend 1 that, frontend 2 depends upon. And so the application would just crash. Maybe it wouldn't crash immediately, but just when you enter, let's say, a page that's driven by frontend 2, it would crash. So they're all now these uncertainties, and it's really hard to deal with. So don't do that. Never make overlapping features in a strongly coupled fashion. And just to reiterate my point, and I don't want to bash single tooling like module federation. Other things, single spa, which was for a long time a very popular orchestrator, it's now not maintained and you shouldn't use it. They already, from the beginning on in their documentation, they, let's say, encourage you to use a way that is exactly this strong coupling, right? So what they say is, every micro frontend you ever want to use, you mention in a so-called root config. Well, that is a bad thing, right? So that means you want to add a new micro frontend, well, someone needs to change the root config. You want to remove a micro frontend, well, good luck with the root config. You want to change the way that when a micro frontend should be active. I mean, why doesn't the micro frontend decide that? Well, but anyway, root config needs to be changed. And you see already, so strong coupling here as well. You have these imports. They already know what micro frontends exist, and that's not good. So in both examples that I've just shown, module federation and single spa, it's not impossible to introduce loose coupling, but it is always something that is a lot more work and is not encouraged by the documentation. And therefore, of course, you see why 9 out of 10 micro frontend projects will now have strong coupling, maybe unknowingly, and will in the long run fail. And very often the story is the same. It always starts good. People say, oh, this is good. Why didn't we do that earlier? 3 months go in and maybe the first deployment and everything still looks rosy, but then suddenly something appears and people start screaming. And suddenly the solution that yesterday appeared like is the best thing since slicing bread is now dog shit. Sorry for the expression. Because of exactly the strong coupling. So don't do that. It's the single most important thing to keep in mind after my talk. Never do Strong coupling in a distributed system because you lose all the benefits of the distributed system. Now, I already mentioned the single thing that microfrontends give you is another dimension to cut your teams. And one possible way is that you now create real full stack teams, which is great. Because this way you could end up with a picture like this, where you say, hey, you've got the application shell, great. And now you have all your services below, and they are fully managed by a single team. And that's great, except, of course, there's one single thing missing. So what are these modules exactly? What are these domains here? Well, you could just look at the screen and say, well, it's good. One of my domain, since I have a web application, is a header. And the second one is a navigation, maybe. And there's a third team called footer. And then there's a content team. Well, I can already tell you that the content team will be rather large, but that the other three teams, they will always be bombarded by requests. So everyone will say, hey, please change my link in the footer. I changed the address. Or, hey, I want to have a different design for me in the navigation, or change the wording here. Now, this will not work out well. So don't do that. Don't print out a screen, draw lines in there and say, these are the micro frontends. That's not how micro frontend should be, let's say, introduced. Instead, what you do is you introduce domains, and now you say, now in this domain, what all belongs there. And at the end of the day, when you remap that to the screen again, you will end up with a picture like that. So you might now have a global layout, but in a global layout, you say, this is a content area. A micro frontend can drive this area and can say, hey, I got now some content to present. That doesn't mean that this content is exclusively done from this one micro frontend. The micro frontend could still say, well, now I got something maybe that another micro frontend wants to show up here. I'm a product information page, and I want to recommendations may show up here if there are some. The same goes for footer, navigation, and header. So these things, they are already shared. They're coming with the app shell from the layout, right? But they say, well, if a micro frontend has something to put into the header or the footer or the navigation, then yeah, just go ahead. And this way, it always stays consistent and it always stays scalable, right? Because now there's not a single footer team or something, and it's actually left to the micro frontends. Now, how does it look in practice? Let's have a look at an example. So here there is a portal of a German company, and they introduced exactly this. So they created also some feature flags, which are, by the way, also dynamic, but you could, of course, toggle it. So now, if you, for instance, remove here a feature, well, suddenly a thing doesn't show up in the menu. So let's activate it again. So this compatibility administration view, and there you see this link for compatibility rules. And even better, it also has a page behind it, right? So there's also some content. Both things are driven, again, by the same idea that you always want to stay consistent, and you leave a micro frontend, well, to make its own decision. And that's good, because from the development lifecycle, it just decouples the things immediately. So you start, for instance, development with an app shell. We will see that in a second. You bring that up to, let's say, a first version where you can work with. And this version is good enough also to start already with some of your core modules. This module, again, is a micro frontend. It might contain some components. As we've seen in the video, there was a component for the navigation, but there was also a component for the whole page. There might be more components, right? Footer, header, whatever you say makes sense. But it's all contained in this module. So they also release it. And then, of course, they are fully independent of this app shell, right? So the app shell stays in production. Maybe they're already working on some fixes and improvements, but you don't care, because you can just release and continue a next version, next version, fixing some issue, adding some features. And the same, of course, goes for other modules that you develop too. And these deployment life cycles, they are not aligned at all. Of course, there might be some reasons why you want to align them. I mean, in general, that's up to you now. That's the beauty of it. But they are independent, right? So yeah, unless you make them dependent on each other artificially or by some technical constraint, well, you end up with a picture like this. They can just deploy whenever they feel ready. And that's great. That's empowering the teams, and that's exactly what you want for scalability. Now, quite often, the problems already arise with the technical implementation. So what you want is a framework, because frameworks, I mean, they help empower you. They help to, of course, make the hard parts easy and give you already, let's say, good boundaries for your solution. Now, the framework I'm going to present is called Pyral. I'm one of the maintainers there, but make no mistake, you can always also just choose to use the ideas of Pyral and maybe use something completely else. So that is fully up to you. Now, what you could, for instance, do as an example, what we will look at is, let's say we have Netflix, famous streaming site for videos, and you want to, let's say, see how you could develop Netflix using micro frontends, in particular using Pyral. So there are already different teams. How would you start? Well, we start, as mentioned, with development of the app shell. So let's have a look how that looks with Pyral. You can do it in the command line. There is a so-called npm initializer. In this case, you want to initialize a so-called Pyral instance. As tooling, we use Webpack 5. We could use any unbundler. And then all the development dependencies are installed for you. This also scaffolds for you a nice boilerplate project that you can then adjust, and we will also adjust in this instance here. Now, when everything's done, we can have a look in VS Code and see what was scaffolded and what we need to change. I will not go into all the details of this change, but in short, what happens here is we have a look at the basic code. The most important part here is a so-called feed URL and a layout. So the feed URL gives you information where you want to get your micro frontends from. These are called pilots in the space of Pyral. And the layout defines essentially how you want to show different things on the page. Now, in this case, we don't want to use that menu and a lot of other things that have been already brought in by this boilerplate. So we don't care. We also don't want to change, let's say, the arrow layout here. But what we definitely want to do is that we want to change the general layout, and we want to introduce the style sheet for an empty application shell that has a Netflix kind of look and feel, right? Now, what we do with this dashboard container, we don't want it. We just go to a custom page called browse. We don't care about this. We don't want notifications. So let's remove all that, all the things we don't need, remove. And change also the layout here. We introduce so-called extension slots. An extension is a component that is coming in from micro frontends, but you don't know from which one. That's also not something you need to say. It's a little bit like an event. So if you have a slot that's like emitting an event, and the other part is of course a listener for an event, and that's the actual component. So that needs to be registered somewhere. So there are always two parts. One part that's saying, here's a slot, so here could be a component shown, and another one who says, I got a component. Now that's the mechanism to, for instance, have loose coupling in the UI and not worry about it anymore, right? Because if there's nothing, there is nothing. You can also think about it a little bit like a web component, because if it's defined, it's great. If it's not defined, then nothing bad will happen either, right? But it's a little bit better than web components in the sense that it also has fallbacks, allows re-rendering, you can have multiple registrations, etc. So things that you also need to take and care about. Great, so we introduced the logo, very important, and then we introduce 300 lines of styles. And finally, we did everything, and we can have a look. We can debug that. So just npm start. It calls Pyro debug, so the CLI. And finally, we end up in our browser. Doesn't look great at this point in time, but it has a logo. It also shows us already that we are on a page where nothing is shown. And this could be now our first draft version of our app shell. So what we do now, we build it. When we build it, we go back and produce two kinds of artifacts. One is a so-called emulator. That's just a TGZ file. This you could, for instance, bring on an npm registry, and that's very easy to share then. And the second thing is that you get release artifacts. So things that you could, in this case, just put on a static file storage, like Azure Blob Storage, for instance, have a CDN in front of it and already have great performance for this. But of course, any other thing you could, I don't know, put it in an Nginx Docker container and just run it anywhere. It's fully up to you. Great. So now we finished the app shell. What's next? Next thing is, of course, we want to have our micro frontends. And for this, we need teams. Now, any kind of, let's say, cut here is good. The cut I've chosen is 3 teams. One is called Inspire. They take care about functionalities such as browsing videos, searching for videos, or favorites. These are 3 different micro frontends, by the way, not 3 components, but it's one team. They may own multiple micro frontends. And there's a second team called users. They just have the profile micro frontend in their hand. And we have a third team called movies. So they know everything about movies, right? And they own the preview of the movies, right? So it's just a static image. Maybe it also has a preview video. And they have the video player in general. So if you click on a video, right, and then you enter the video player, that's a quite crucial component for any kind of micro frontend. And you could expect that this micro frontend that will get quite some updates, because there's always something to improve, bugs, etc. Different formats that need to be supported, whatever. Great. Now, how does a team deal with that? Let's see how this favorites micro frontend could be scaffolded. Again, could be all done via the command line. npm init pilot is here the command. And they now need to give it a source for an emulator. So that's the TGZ we created beforehand. As bundler, they're using ESBuild, so not Webpack, because that's what this team likes, right? So different teams might use different tooling. They don't care. And one scaffold, they can already start it. And here you can see it. They run it already in the emulator, and it looks, well, blank. But they could do more, right? So for instance, since this is a framework, this is an ecosystem, they can use a browser extension. And using this extension, they can manipulate also the solution. And what we can see here is they also can load in additional micro frontends that already exist in the feed. So in this case, they loaded in the browse pilot, watch pilot, search, and profile pilot. And they can even see how it behaves when you disable and enable different micro frontends, right? What you can also do is, of course, you can visualize now where all these components come from, right? That you can see, oh, this whole page comes from the browse pilot. That's not a surprise. But then we got, for instance, the search here. We got the profile, and the watch pilot brought in all these preview images that you can see, right? So that being said, that's how it looks in a nutshell. Now, if you develop the favorites extension, and we will go over that in a second, what is the most important part, right? That it remains loosely coupled. So the extension, or let's say the favorites functionality, it should embed itself like very naturally on the page, right? It shouldn't be a separate page directly, etc. It should be visible, for instance, in all the preview of the movies. So you should already see, for instance, this kind of a checkbox. So what we want is that in already this movie tile that comes from the watch micro frontend, you now want to have an additional component that's coming from another micro frontend. But both micro frontends should know each other, because otherwise, I mean, again, you're in the strong coupling case. And if you, let's say, expand that view, then you will see that, for instance, you might also want to bring in a menu here. So here you have your favorites menu. You might want to have other things in here, but it's all composed, as we've seen already, from the different microfrontends. So with that in mind, let's have a look now in our editor. We are here in the favorites pilot, so the microfrontend. As you can see, already there is some code existing here. Part of the code was scaffolded beforehand and makes it possible to run, for instance, now the debug on it. And what we have in order to establish that is a kind of a plugin model. So what your microfrontend is, in essence, is a library of JavaScript code that has a single export called setup. There are other exports too, which are optional, but the important one and the required one is called setup. And it receives an API object. Now, this API object was tailored and made only for this microfrontend. It is not shared with other microfrontends. Nevertheless, it has an API on top of it that allows this microfrontend now to interact with the application shell and do things. So in this case, for instance, we say we register menu entry, and we call it favorites, and we register a page, and we register it at the /favorites route, and we register our extension, right, the list toggle. And here it is, right? Now, if we do that, then we will see the following. And forgive me, this image here is broken. Someone removed it. So I think Pablo Escobar will not be happy here. But nevertheless, this is exactly the application we've seen before in the video. Now, only that the favorites microfrontend is loaded. It comes up with its page, right? And yeah, we should, of course, start the debugging process. I didn't do that. Otherwise, we will not be able to load it. Importantly, we start out that all locally, right? So that is the whole idea behind these two artifacts from the app shell, right? That we have the emulator, because that allows us now to locally develop and not requiring, I don't know, a different environment or something up there and whatnot. So this is a quite powerful concept. So let's load it again. And we see now Narcos was added, and you already have here the check mark. And what you can, of course, do is you hover over these different things, and you now see, for instance, the heart here appearing too. So if you click on it, right, so now it was also put to the favorites. Now that's dirty linen, whatever the show is. And now I got the two shows in here, right? And I can interact with it very naturally. Now I debookmarked it. Again, that all flows in naturally. So you now have this button in here. You have now this button. And if you look in your browser, I have here the Parallel Inspector installed, right? And already some pilots are already loaded. If I would remove the favorites, it would just remove this part here, this part, and we don't see this. So it really composes very naturally because, again, these things are loosely coupled, and that means you can also just enable and disable on demand. So very, very nice. The whole sample is on GitHub. If you want to know more, just ping me. And with that being said, I'm already at the end of my time, at the end of my talk. Just reach out to me in Gathertown, connect to me on LinkedIn. I don't know, follow me on Twitter. Let's get in touch. If you have any questions, want to exchange ideas, I'm always very happy to get in touch with you. Thanks and have a great conference.